When rumors surfaced that Tesla might launch a new model priced under $20,000, many asked the same question. With a price that low, can it really be any good, or will it be a cheap car that ends up draining your wallet on repairs and headaches?
But we've been targeting the low cost of ownership. Monthly payment is the biggest differentiator for our vehicles, and that's why we're focused on bringing these new models with the lowest price to the market.
Now, Elon Musk has finally announced the secret behind it.
We source LFP battery cells from China. We're in the process of commissioning equipment for the local manufacturing of LFP battery cells in the US.
A breakthrough aluminum battery that could slash production costs while making the car safer and cheaper to maintain than anything we've seen before. So how can it make a Tesla cheaper than anything on the road today? In this video, we break down the facts that why this battery innovation could finally make owning a Tesla not just possible, but practical for everyday Americans. If you're tired of the hype and want real facts that matter, you're in the right place. Hit subscribe and ring the bell to help OCEANTECH reach our first 111 subscribers. And get trusted data, clear analysis, and expert insights straight to your feed. Why this aluminum battery could be the game changer we've been waiting for. One of the biggest barriers to owning an electric vehicle has always been the cost. Not just to buy it, but to maintain and charge it. And a major part of that cost comes from the battery. Today, Tesla is betting on a new kind of battery, one made from aluminum, the most abundant metal on Earth, to bring the price of its new Model 2 down to under $20,000, while making it safer, easier to maintain, and even cheaper to charge. Most electric vehicles today use lithium-ion batteries, which are efficient but expensive. They rely on costly and limited resources like nickel, cobalt, and lithium, all of which are subject to volatile global markets. In fact, just the battery pack alone in a typical EV can cost $7,000 to $12,000, nearly half the cost of the car. Aluminum batteries, by contrast, use aluminum as the anode, which costs only around $2,500 per metric ton compared to lithium, which reached over $11,000 per metric ton in early 2025. This makes the raw materials significantly cheaper and more stable in price, helping slash production costs by up to 40%, according to estimates from energy analysts. Aluminum batteries aren't just cheaper, they're safer. While lithium-ion batteries are linked to about 25 fire incidents per 100,000 EVs annually, aluminum batteries run cooler and are far less prone to overheating or combustion. They also retain 85 to 90% capacity after 2,000 charge cycles, compared to 70 to 80% for typical lithium-ion packs, meaning fewer replacements and lower maintenance. For older drivers or families, that's real peace of mind and long-term savings. They also charge faster. Early lab tests from institutions like Stanford have shown that aluminum-ion prototypes can fully charge in under 10 minutes compared to 30 to 60 minutes for most current EVs. And because they don't need ultra-high voltage, they may allow charging from a standard 110-volt wall outlet, perfect for homeowners without access to special equipment. Do you think a $20,000 EV with a safer, faster-charging aluminum battery could finally make you switch to electric? Comment Model 2 if you're in. Along with producing the Model 2 at gigafactories like Giga Mexico, where labor costs are around $4 per hour versus over $30 in the US, Tesla could cut manufacturing costs by $3,000 to $5,000 per vehicle. Tesla's next-gen manufacturing, featuring unboxed assembly, single-piece Giga castings, and structural battery packs, could reduce costs by 30% to 50% compared to the Model 3. Simple the design from over 2,000 moving parts to fewer than 20 lowers complexity, speeds up production, and reduces mechanical failures. When Tesla integrates aluminum battery tech into its manufacturing, the battery pack cost could drop below $60 per kilowatt-hour, down from today's average of $120 to $150 per kilowatt-hour. With the Model 2 rumored to have a 40 to 50 kilowatt-hour battery, this alone could save $2,400 to $4,500 per vehicle. So, The highly anticipated Model 2 could be priced in the range of $20,000 to $22,000, even before applying any federal tax credits. That's nearly 50% lower than the current average price of an electric vehicle in the U.S., which stood at approximately $53,000 in early 2025, according to Kelley Blue Book. According to industry forecasts, lithium iron phosphate LFP batteries, and particularly newer aluminum-based variants, are expected to be introduced across a much broader range of Tesla models beyond just the upcoming Model 2. While LFP batteries are already used in some of Tesla's vehicles in select markets, the next generation of these chemistries, especially those incorporating aluminum as a key component, could dramatically improve cost efficiency, supply chain stability, and safety. Implementation of these advanced batteries is reportedly planned to begin with production updates starting in late 2025, signaling a major strategic shift in Tesla's long-term electrification roadmap. By moving away from expensive and supply-constrained materials such as lithium, nickel, and cobalt, Tesla is positioning itself to drastically cut production costs across its entire vehicle lineup. These raw materials, commonly used in traditional lithium-ion battery chemistries, are not only costly, but also vulnerable to geopolitical tensions, environmental regulations, and fluctuating global demand, all of which drive price volatility and supply instability. By transitioning to alternative battery chemistries, such as lithium iron phosphate, LFP, or even next-generation solid-state or sodium-ion batteries, Tesla can build a more resilient and cost-effective supply chain. This strategic shift doesn't just benefit Tesla's manufacturing margins, it also translates to tangible savings for consumers. Entry-level electric vehicles could become significantly more affordable, making them accessible to a wider demographic, including students, young professionals, and budget-conscious drivers who may have previously been priced out of the EV market. But the impact doesn't stop at the lower end of the spectrum. Even mid-range and premium models like the Model 3 and Model Y could see price reductions, enhanced value, or better performance per dollar ratios. This could lead to a broader adoption of EVs in mainstream markets, further accelerating Tesla's mission to transition the world to sustainable energy. So, what do you think? Would a $20,000 Tesla with faster charging and lower maintenance be enough to convince you? Let us know in the comments below, we will discuss it together. But the big question remains: when will we actually see aluminum-ion batteries and the real Model 2 hit the roads? Stay tuned. And don't forget to like, subscribe, and turn on notifications so you never miss an update on the future of transportation, from breakthrough battery tech to the most affordable electric vehicles reshaping the roads.